How are you all? Yes, we will study about fluid. Unit 3, Unit 3, Physics, Unit 3, fluids. Already we studied two parts. Now, third part, density. Yes, first two part everybody studied. Homework written. Yes, children, now we will study about density. Okay, density. You know density? Density is a comparison of how much matter there is in a certain amount of space. Density is a comparison of Density is a comparison of how much matter there is in a certain amount of space. Which square is more dense? See the picture? Yes. Density. Now we will see one activity for the density. What is the SI unit of density? Kilogram per meter cubic. Kilogram per meter cubic. Also in gram per centimeter cubic. Gram per centimeter cubic. The symbol of the density is rho. Rho. Like P. Yes, that is a rho. What is density? The density of a substance, the mass per unit volume of a given substance. Density of the substance is the mass per unit volume. Mass per the unit volume of a given substance. Mass per the unit volume of the given substance. Okay. Comparison, how much matter, that is certain amount of space. That is the density. Okay. Now, activity I will give. See the picture, everybody. That like two identical flasks, take it. Fill one flask with water to 250 centimeter cube. Mark and other with kerosene to the same 250 centimeter cube mark. Measure them in a balance. Measure them in a balance. We will measure that one. Kerosene, how many gram? That like we measure. Okay. The flask filled with water will be heavier than the one filled with kerosene. The flask filled with water will be heavier than the one filled with kerosene. Why? Water measurement is more. Two are measured. Water will be heavier than the kerosene. Why? You know why? Finding the mass per minute volume of kerosene and water is respective flask. To understand density better, let us assume that the mass of the flask be 80 gram. 80 gram. Mass of the flask 80 gram. So the mass of flask filled with water is 330 gram. 330 gram. Why 330 gram? The flask 80 gram, water 200 milli, 250 milli. So 330 gram. And the mass of flask filled with kerosene is 280 gram. Mass of kerosene. Mass of flask filled with water is 330 gram and mass of flask filled with kerosene is 280 gram. Mass of water only 250 gram and kerosene only in 200 gram. Mass per unit volume of water is 200 by 200 centimeter cube. This is 1 gram per centimeter cube. Mass per unit volume of kerosene is 200 gram per 250 gram centimeter cube. This is 0.8 gram per centimeter cube. The result 1 gram per centimeter cube and 0.8 gram centimeter cube are the 10 density of water and kerosene. Density of water is 1 gram per centimeter cube. Density of kerosene 0.8 gram centimeter cube. Okay, have you understood? Therefore, the density of substance is the mass per unit of volume of a given substance. So, density of substance is the mass per unit volume of a given substance. Okay, children, have you understood? SI unit of density kilogram per meter cubic, kg per m3 meter cubic. Also gram per centimeter cubic. The symbol for density is rho. Symbol for density is rho. That's like P. Okay, children. Kerosene water density is different. Water density is 1 gram per centimeter cubic. Kerosene 0.8 gram centimeter cubic. Okay, do you understood? Okay, we have relative density. Relative density. We can compare the densities of two substances by finding their mass. Finding their mass. Two substances finding their mass. But generally, density of substance is compared with the density of water. Substance compared with the density of water at 4 degrees Celsius. At 4 degrees Celsius water. Density of water at 4 degrees Celsius. Because the density of water at the temperature is 1 gram per centimeter cubic. Density of any other substance with respect to the density of water at 4 degrees Celsius is called the relative density. Relative density. What is relative density? The relative density of the substance is defined as the ratio of density of substance to the density of water at 4 degrees Celsius. Density of substance to density of water at 4 degrees Celsius. It is also known as specific gravity of the substance. Relative density, otherwise specific gravity of substances. Specific gravity of substances. Okay. Relative density, the relative density or D. What is the formula of relative density? Density of the substance by density of water at 4 degrees Celsius. That only the definition also given. Yes. Relative density is equal to density of substance by density of water at 4 degrees Celsius. Otherwise, we can say like this: mass of any volume of substance by mass of same volume of water at 4 degrees Celsius. Mass of any volume of substance, mass of same volume of water at 4 degrees Celsius. Okay. Relative density has no unit since it is the ratio of two similar physical quantities. Okay. No unit. Two similar physical quantities. Ratio of two similar physical quantities. Density of every substances is expressed relative to the density of water at 4 degrees Celsius. Okay, relative to the density of water at 4 degree Celsius. Example, the density of gold is 19,300 kilometer per meter cube. The density of water 1000 kilogram per meter cube. So we will write like this. Relative density of gold is equal to density of substance by density of water at 4 degrees Celsius. Density of substance is gold, that is 19,300 kilometer per meter cube by 1000 kilogram per meter cube is equal to 19.3. 19.3. So relative density of gold is 19.3. Okay, have you understood? Yes. Relation between the density and relative density. Density and relative density. What is the difference? CGS system. Density of substance in 9 centimeter cubic, 1 gram centimeter cubic. SI system. Density of substance in kilogram meter per cubic, 1 kilogram meter per cubic. Okay, this is the density and relative density relations, between the relations. Density in kilogram meter per cube is equal to relative density multiply 1000. Multiply 1000. Have you understood, children, everybody? Yes. Thus, the ratio of mass given volume of substance to the mass of equal volume of water at 4 degrees Celsius denotes relative density. Okay. Now, we will see the measurement of relative density. Measurement. How do you measure the relative density? Pycnometer. Pycnometer. Relative density can be measured using pycnometer, also called density bottle. Density bottle. See the picture, everybody? Density bottle. Okay? Yes. It consists of ground glass stopper with a fine hole through it. The function of hole in a stopper is that when the bottle is filled and stopper is inserted, water is filled, stopper is inserted. See the picture. Like the liquid rises through the hole and run down outwards the bottle. By this way, the bottle will always contain the same volume of whatever the liquid is filled in, provided the temperature remains constant. Thus, the density of given volume of substance to the density of equal volume of reference substance is called relative density or specific gravity of the given substance. Relative density or specific gravity of given substance. If the reference substance is called is water, then the term specific gravity is used. Specific gravity is used. Pycnometer is a device used to measure the value of density or the density of fluid. Pycnometer. Okay. Pycnometer only measuring the relative density. This hole, the function of hole in the stopper is that when the bottle is filled and the stopper is inserted, the excess liquid rises through the hole and run down outside the bottle. Run down outside the bottle. By this way, the bottle will always contain the same volume of whatever a liquid is filled in, provided the temperature remains constant. Thus, the density of a given volume of substance to the density of equal volume of reference without reference substance is called relative density. Okay, yes, everybody saw the picture. Relative density can be measured by picnometer. Okay, relative density measured by picnometer. Okay, next one we floating and sinking. மிதக்கிறது மூழ்குகிறது. See the picture. One small duck. Yes, that I think it is a toy. That is floating. Yes, yes. Someone we are put inside the water means that will sinking. Yes or no? Floating. If the weight of object is less than beyond force, the object will float. Okay? Floating means what? இந்த தண்ணிக்கு ஒரு பயாண்ட் ஃபோர்ஸ் இருக்கு. மேலே உந்த தள்ளுகிற ஒரு ஃபோர்ஸ், மேலே உந்து தள்ளுகிற ஒரு ஃபோர்ஸ் இருக்கு. அதான் பயாண்ட் ஃபோர்ஸ். அந்த பயாண்ட் ஃபோர்ஸை விட இந்த வெயிட் அதிகமாக இருந்துச்சுன்னா, அந்த ஃபோர்ஸை விட வெயிட் அதிகமாக இருந்துச்சுன்னா அது என்ன செய்யும்? மூழ்கிடும். Okay? If the weight of the object is exactly equal to the beyond force, the two forces are balanced. So that will float. Understand? பியாண்ட் ஃபோர்ஸ்னு வாட்டரில் ஒரு ஃபோர்ஸ் இருக்கு. வாட்டர் எப்போ என்ன பொருளை உள்ளே போட்டாலும் கொஞ்ச நேரத்தில் அது இது மேலே வந்துடும். நம்மளும் கொஞ்ச நேரம் உள்ளே போயிட்டோம் அப்படின்னாலும் ஒரு நாளுக்கு மேலேயாவது மேலே 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 வந்து மேலே வந்துடும். ஓகே, எஸ், தட் ஒன் கைண்ட் ஆஃப் ஃபோர்ஸ், upward force, that is a beyond force. The beyond force விட the things weight அதிகமாக இருந்துச்சுன்னா மூழ்கிடும். That is sinking. Beyond force and the weight of the object is equal means that will balance, that will not sink, that will float. Okay, that is a floating and sinking. Floating and sinking. So whether an object will sink or float in the liquid determined by the density of the object. Density determined by the density of the object compared to the density of the liquid. If the density of the substance is lesser than the density of the liquid, it will be float. For example, a piece of wood which is less denser than what will float on it. You see, piece of wood, you know, yes, that will float or sink. It will less dense than water, will float on it. Okay, it will float on it. Any substance having more density than the water, for example a stone, will sink into it, sink into it. Okay, that means density. Floating and sinking determined by the density of the object. Floating and sinking determined. Liquid is determined by the density of object. So for example piece of wood, and that will float. Another example, stone, that will sink into the water because stone density is more than water. Okay, yes, piece of wood density is lesser than water. Okay, yes, one problem is also given here. Problem 5, page number 33. Everybody open the book, page number 33. Problem 5. You have a block of mystery material 12 centimeter long, 11 centimeter wide, and 3.5 centimeter thick. Its mass is 1155 grams. What is its density? Will it float in a tank of water or sink? Okay, now we will find the density. After that will float or will sink, that we will see. See the book. Density, mass by volume. Mass is equal to 1155 gram. Volume 12 centimeters, 11 centimeter, 3.5 centimeter. Multiply. Okay, that we get 462 centimeter. So 1155 gram by 462 centimeter is divided by 2.5 grams centimeter cubic. 2.5 gram centimeter cubic. The mystery material is denser than water. What is the density of water? 1. Yes, what is the density of water? I said, what is the density of water? 1 gram per centimeter cubic. 1 grams per centimeter cubic. Here, the density of this material 2.5 gram centimeter per cubic. So, the substance is more density. So, water is a less density. So, this mystery material is denser than the water. So, it sinks. So, it sinks. Have you understood, children? Have you understood? Floating, sinking. Everybody understood? Okay. Next, we have to see application of principle of flotation. Application of principle of flotation. மிதக்க வைக்கிறது. Okay. Here one hydrometer. Hydrometer, anybody saw? Hydrometer. It is hydrometer. Everybody see the picture. It is hydrometer. A direct reading instrument used for measuring the density or relative density of liquid is called hydrometer. Measuring the density or relative density of the liquid called hydrometer. Okay. Hydrometer is based on principles of flotation. இதுக்கு பிரின்சிபலே என்னது? ஃப்ளோட்டேஷன். மிதக்குகிறது, மிதத்தன்மை உள்ளது. Hydrometer is based on the principle of flotation, that is the weight of liquid displaced by the immersed portion of the hydrometer is equal to the weight of the hydrometer. Weight of liquid displaced by the immersed portion of the hydrometer is equal to the weight of hydrometer. Hydrometer consists of cylindrical stem having a spherical bulb. You see the picture? Cylindrical stem, spherical bulb. That one covered. Yes, the bulb we can't see. We can't see the bulb. Yes. Yes. See the picture. The bulb is the lead shot. Lead shot. Consists of cylindrical stem having spherical bulb at its lower end and a narrow tube at its upper end. Narrow tube upper end. The lower spherical bulb is partially filled with lead shot. Everybody see the book. Lead shots or mercury. This helps hydrometer to float or stand vertically. This hydrometer to float or stand vertically. மிதக்கும் அல்லது அப்படி மேலே ஸ்டாண்ட் பண்ணி நிற்கும் தண்ணிக்குள்ள. Stand vertically in liquids. The narrow tube has marking so that the relative density of liquid can be read directly. See the picture? Marking. Yes. Marked. Numbers are there. So we can easily read directly. We can read. The liquid to be tested is poured into the glass jar. The hydrometer is gently lowered to the liquid until the float freely. The reading against the level of liquid touching the tube gives the relative density of the liquid. So, hydrometer may be calibrated for different uses such as lactometers for measuring the density of milk. Lactometer, heard about anybody? Lactometer. That is lacto. Lacto means milk. Yes, measuring the density of milk. Measuring the density of milk. Lactometer. Hydrometer or liquid. Lactometer measuring the density of milk. Saccharometer. Saccharo. Saccharo means sugar. Saccharo means what? Sugar. So measuring the density of sugar in a liquid. Liquid. Sugar. Sugar in a liquid. And algagolometer. Algagolometer for measuring higher level of alcohol in spirits. Hydrometer. Three hydrometer example given here. Lactometer, saccharometer, algagolometer. Lactometer, that is measuring the density of milk. Saccharometer measuring the density of sugar in a liquid. Algalometer measuring the higher level of alcohol in spirits. Okay, these are hydrometers. These are hydrometers. Okay, hydrometers. These always floating, sometimes vertically, sometimes floating on the surface. Okay, hydrometer. Okay, now we have to see the lactometer. Anybody saw the lactometer? See the picture, everybody. Lactometer. Lacto, measuring the density of milk. Lactometer. What is lactometer? This one measuring the density of milk. One form of hydrometer is the lactometer. It is an instrument used to check the purity of milk. பால் சுத்தமா நல்லா கரெக்டா இருக்கா, தண்ணி ஊத்தாம இருக்குதா, அதை வெரிஃபை பண்ணதுக்கு தான் இந்த லாக்டோமீட்டர் யூஸ் பண்றாங்க. The lactometer works on the principle of gravity of milk. Gravity of milk. The lactometer consists of long graduated test tube. See the picture? Long graduated test tube with the cylindrical bulb. Cylindrical bulb. Long test tube and a cylindrical bulb with the graduation ranging from 15 at the top to 45 at the bottom. 15 at the top to 45 at the bottom. Ranging from 15 at the top to 45 at the bottom. 15 இருந்து 45 மேல இருந்து கீழே வரும். Okay, 15 at the top to 45 at the bottom. The test tube is filled with air. This air chamber causes instrument to float. இதை இந்த பாலுக்குள்ள போட்டோம்னா இது மிதக்கும். Why? Because this lactometer inside air is there. So only that will float. The spherical bulb is filled with mercury to cause the lactometer to sink up to the proper level and to float in an upright position in the milk. The lactometer sinks up into the proper level and float in the upright position of the milk. எதுவரை அது மூழ்கணுமோ அது வரை மூழ்கும், எதுவரை ஸ்ட்ரெயிட்டா நின்று மேல உள்ள பொசிஷனை காட்டும். அப்ரைட் த பொசிஷன் இந்த மில்க். மேல பால் எவ்வளவு மேல வரை இருக்கோ அதுக்கு மேல அந்த அளவு போல மேல கொஞ்சம் காட்டிட்டு இருக்கும். That is lactometer. Inside the lactometer there may be a thermometer. Inside the lactometer, thermometer is there, extending from the bulb up into the upper part of the test tube where the scale is located. Upper part, the scale is located because we can see the scale, how much density. We can see the density of the milk. Okay, the scale is there. Inside the lactometer, there may be a thermometer. The correct lactometer reading is obtained only at a temperature of 60 degree Fahrenheit. Temperature of 60 degree Fahrenheit. A lactometer measures the cream content of milk. பாலில் எவ்வளவு கொழுப்பு சக்தி இருக்குது அப்படின்னு கண்டுபிடிக்கலாம். ஓகே, more the cream, lower the lactometer float in the milk. The average reading of normal milk is 32. The normal milkல average reading 32ல இருக்கும். Lactometer are used at milk processing units and dairies. Lactometers are used at milk processing units, dairies and dairies. Okay, lactometer, everybody understood, children? Yes, lactometer is measuring the milk, density of milk, measuring the density of milk. Okay, now we have to see buoyancy. What is buoyancy? Buoyancy is an upward force exerted by the fluid that opposes the weight of the immersed object. In a column of fluid, pressure increases with depth as a result of the weight of the overlying fluid. Overlying fluid. Buoyancy is an upward force exerted by the fluid. Upward force. Already saw that body experience and upward force due to fluid surrounding when it is partially or fully immersed into it. Partially or fully immersed into it. We also know that pressure is more at the bottom and less at the top of the liquid. Already we studied the every liquid less pressure in the top and more pressure in the bottom. This pressure difference causes the force of object and pushes it upward. This causes only the pressure is upward very less, that depth, that is the bottom of water, otherwise bottom of the liquid, more pressure are there. So this pressure differences causes a force on the object and pushes it upward. இந்த ப்ரெஷர் கீழே இருக்கிறதுனால தான் இது வந்து the things என்னது மேலே தள்ளுது. Okay, difference causes force on the object and pushes it upward. This force is called buoyant force and the phenomenon is called buoyancy. This force is called buoyant force and this phenomenon is called buoyancy. Everybody see the picture. Buoyancy. Upward movement. Upward force exerted by the fluid. Okay, see the picture. The ball is floating on the surface of the water. Yes, most buoyant objects are those which are relatively high volume and low density. If the object is weightless than the amount of water it has displaced, buoyant force will be more and it will be float. Buoyant force will be more and it will be float. Such object is known as positively buoyant. But if the object weighs more than amount of water it has displaced, buoyant force is less and the object will sink. Such object is known as negatively buoyant. Have you understood? Negatively buoyant, positively buoyant. Yes, positively buoyant means what? Positively buoyant means buoyant force will be more and it will be float. That is positively buoyant. The buoyancy, the force will go upward. The force is going upward. So more force, buoyant force means that will float. That is a positive buoyant. Positive buoyant. The negative buoyant, what is negative buoyant? The force, upward force, more than amount of water. That means buoyant force is less and object will sink. Buoyant force less, object will sink. Buoyant force more, object will sink. Buoyant force more, object float. Buoyant force less, object will sink. Okay, have you understood, children? Yes. Buoyant force is an upward force exerted by the fluid. Okay, why this buoyant force? The the pressure is more than at the bottom and less at the top of the liquid. This pressure difference causes the force on the object and pushes it upward. ஃபோர்ஸ் வந்து கீழே அதிகமாகவும் மேலே லெஸ்ஸாகவும் ப்ரெஷர் இருக்கிறதுனால இந்த ஃபோர்ஸ் வந்து மேலே மரம் வந்துட்டே இருக்கும். இந்த ஃபோர்ஸ் பயாண்டு ஃபோர்ஸ். இந்த பயாண்டு ஃபோர்ஸ் லெஸ்ஸாக இருந்துச்சுன்னா இப்போ திங்ஸ் எல்லாம் மூழ்கிடும். பயாண்டு ஃபோர்ஸ் வந்து மோராக இருந்துச்சுன்னா திங்ஸ் எல்லாம் மிதக்கும். ஓகே, have you understood, children? Now we have to see Cartesian diver. Cartesian diver. Here, one diver dive inside the water. Here, experiment that demonstrated the principle of buoyancy. It is a pen cap with clay. நம்மளே இதை செய்யலாம். ஒரு பென் கேப்பில் கொஞ்சம் கிளேயை நல்லா ஒட்டி வச்சிடணும். ஒட்டி வச்சுட்டு தண்ணிக்குள்ளே போடணும். A Cartesian diver contains just enough liquid that is partly float in the bath of liquid. Its remaining volume is filled with air. When pressing the path, the additional water enter the diver, thus increasing the average density of diver, and thus it sinks. போட்ட உடனே அப்படி முங்காது, மெதுவாக அதில் கொஞ்சம் ஏர் இருக்கிறதுலாம் என்னதாகும், bath of a liquid filled with air. Pressing the path, additional water enter into the diver. Water enter into the diver, thus increasing the average density of the diver. After it will sink. After it will sink. Okay, air will expand and not squeezed. Large buoyancy. Okay, air will compress then squeezed hard. Yes, this in the book we can do this one. The Cartesian diver we can do and see in your home. Okay, children. Next one we have to Archimedes principle. Archimedes principle. Here, Archimedes principle. What is Archimedes principle? Archimedes principle is the consequence of Pascal's law. According to Legend, Archimedes devised the principle of the hydrostatic balance after he noticed his own apparent loss in weight while sitting in his bath. The story goes that he was so enthused with his discovery that jumped out of his bath and ran through the town shouting, Eureka, 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 Eureka. Archimedes' principle states that a body immersed in a fluid experienced the vertical upward beyond force equal to the weight of fluid it displaces. This is very easy one. See the picture. One weight, a 5 kilo weight is there. 5 kilo weight. அந்த 5 கிலோ வெயிட்டை அப்படியே அந்த லிக்யூடுக்குள்ளே தண்ணிக்குள்ளே கொண்டு வரோம். தண்ணிக்குள்ளே கொண்டு வந்தோடனே கரெக்டாக அந்த தண்ணி முடிந்த இடத்துல ஒரு கேப் இருக்கும், வெளியே தண்ணி வர மாதிரி. See the picture. After that will keep it inside the water. இந்த 5 கிலோவையும் வெயிட்டையும் உள்ளே அழுத்தணும். உள்ளே அழுத்தினோடனே அந்த வெயிட் எப்படி செய்யுது, அப்படியே தண்ணியை வெளியே தள்ளுது. How many kilo? 5 kilo. So the water also coming out. Some water, little water coming out. When a body is partially or completely immersed in fluid at rest, it experiences an upthrust which is equal to the weight of fluid displaced by it. Equal to the weight of the fluid displaced it. எவ்வளவு வெயிட் உள்ள போச்சோ அதே தண்ணி அளவு வெளியே வந்துடும். Due to the upthrust acting on the body, if it apparently loses part of its weight and apparent loss of weight is equal to the upthrust. Upthrust. Okay, upthrust is equal to the weight of the fluid displaced. Yes, how much water, how weight is coming, that like water also coming out. Water also coming out. Upthrust is equal to the weight of fluid displaced. For the either partially or completely immersed in a fluid, upthrust is equal to weight of the fluid displaced, apparent loss of weight of the body, apparent weight of an object, true weight of an object in air, upthrust, weight of water displaced, weight of water displaced. How much weight is going inside the water, that much water is coming out. Okay, water is coming out. So it is the upthrust is equal to the weight of fluid displaced. Okay, Archimedes principle. It is Archimedes principle. How to see the law of flotation. Law of flotation. Law of flotation. Law of flotation are the weight of floating body in a fluid is equal to the weight of fluid displaced by the body. The Archimedes principle also like this. Weight of floating body in the fluid is equal to the weight of fluid displaced by the body. The center of gravity of the floating body and the center of buoyancy are in same vertical line. Same vertical line. Buoyancy line. Center of buoyancy. Buoyancy. See the picture? In the book also see buoyancy. The center. Center of gravity of floating body and the center of buoyancy are in the same vertical line. See, same vertical line. Center of gravity of floating body, center of buoyancy are in the same vertical line. The point through which the force of buoyancy is supposed to act in known as center of buoyancy. Center of buoyancy. So, the weight of floating body in the fluid is equal to the weight of fluid displaced by the body. Displaced by the body. Center of gravity of the floating body and the center of buoyancy are in the same vertical line. Okay, it is center of buoyancy. This is a law of flotation. Law of flotation. This lesson completed. Okay, fluid. That lesson completed. So everybody study this lesson properly. Okay, fill in the blanks. Small questions, one word questions given. You write it in the class homework note properly. Write 10 fill in the blanks. In this part 10 fill in the blanks given. Yes, classwork page number 33 problem 5. Page number 33 problem 5. Okay, this is your classwork. Homework fill in the blanks 10. Okay, this lesson everybody study properly. The problems some also do and see in book back questions. Yes, book back questions, test book exercise. Everybody take your guide and write it this all. Okay, fill in the blanks, choose the correct answer, and assertion and recent type questions, answer in brief, answer in details, to study in the guide. Okay, okay children, your test next week. Everybody study properly. Everybody study properly. Yes, yes children, everybody study. Yes. Write the homework neatly. Okay, thank you.